रेडियो खांची 90.4 एफएम पर प्रसारित किए जाने वाले विषय वस्तु का सारा क्रेडिट प्रस्तुतकर्ता को दिया जाता है। हमारा मकसद है समाज में ज्ञान एवं सकारात्मकता को आगे बढ़ाना।
रेडियो खांची 90.4 एफएम हम सबका रेडियो। आई एम डॉक्टर जीनत परवीन, असिस्टेंट प्रोफेसर, डिपार्टमेंट ऑफ मैथमेटिक्स, डोंडा कॉलेज, डोंडा। In my first lecture, I had discussed the basics of integral equation and classification of integral equation, which is Fredholm and Volterra integral equation, and given special attention on Fredholm integral equation. Today, I am going to discuss about the Volterra integral equation with examples and their kinds. In Volterra integral equation, both the limits of integration are not constant. That is, the Volterra integral equation is given by u as function of x into h as function of x equal to f as function of x plus lambda into integration of k as function of x comma t into u as function of t into dt, which is equation 1, and the limit varying from a to x. In other words, we can say that if any one or both the limits of integration are variable, then the equation is called Volterra integral equation. For example, sin x equal to integration of sin x as function of x plus t into u as function of t into dt, which is equation 2, and the limit varying from 0 to x. Now, if taking h as function of x equal to 0 and f as function of f is not equal to 0 in equation 1, then we get f as function of x plus lambda into integration of k as function of x comma t into u as function of t into dt equal to 0, which is equation 3, and the limit varying from a to x. So this equation is called non-homogeneous Volterra integral equation of first kind. Another example of this equation is 2x plus 5 into integration of sin as function of x plus t into u as function of t into dt equal to 0, and the limit varying from 0 to x. Now, if h as function of x equal to 1 and f as function of x is not equal to 0 in equation 1, then the given equation reduces to equation 4, which is u as function of x equal to f as function of x plus lambda into integration of k as function of x comma t into u as function of t into dt, and the limit varying from a to x. So this equation is called non-homogeneous Volterra integral equation of second kind. For example, u as function of x equal to x plus integration of xt into u as function of t into dt, and the limit varying from 1 to x is called non-homogeneous Volterra-integral equation of second kind. Now the next, if taking h as function of x equal to 0 and f as function of x equal to 0 in equation 1, then the given equation reduces to equation 5, which is lambda into integration of k as function of x comma t into u as function of t into dt equal to 0, and the limit varying from a to x. So this equation is called homogeneous Volterra integral equation of first kind. Now another example is 2 integration of sine x into as a function of x plus t into u as function of t into dt equal to 0, and the limit varying from 0 to x. Now if h as function of x equal to 1 and f as function of x equal to 0 in equation 1, then the given equation reduces to equation 6, which is u as function of x equal to lambda into integration of k as function of x comma t into u as function of t into dt, and the limit varying from a to x, called homogeneous Volterra integral equation of second kind. Now the second example of homogeneous Volterra integral equation of second kind is u as function of x equal to 2 into integration of xt into u as function of t into dt, and the limit varying from 1 to x. So we can see that the first kind has one dependent variable and the second kind has two dependent variable u. In the next class, I shall discuss the type of integral equation. Thank you.